So there were two questions in class today about steel that I couldn't answer. So I visited with my postdoc, who is an expert in steels and have answers. First question was about this figure. And the question was about what's the difference between coarse perlite and fine perlite. And the answer is coarse perlite is coarse and fine is fine. I know, sounds obvious, but no, it really has to do with the size of the grain structure. And from what it sounds like, you can't determine that from a TTT curve. You really need a CCT curve, such as this. And when you're operating over here, where you have a relatively slow cooling, you're going to have a coarse structure. And when you're operating over here, you have to be within the critical cooling curve. But over on this side, you're going to have a fine structure because you have a more rapid cooling rate. The second question was about this problem 10.20, and in particular part C, which was about how to get the coarse perlite, bainite, and martensite. So what I showed in class was a path in which the cool down went into the perlite or austenite to perlite transformation, stopped at 50%, quenched, and then went into the austenite to bainite, and then quenched to martensite. And the way I drew the curve, it came down and then back and forward. And the question is, are we going backward in time? No, we're not going backward in time, but what was explained to me is that you cool down, you come over, and when you quench, moving from the austenite to perlite into the austenite to bainite transformation regime is essentially restarting time. So you've quenched it in some type of salt bath, take it back over here, and then you're holding it at constant temperature and you're passing back in. So the quench locks in the perlite, and then the austenite, the remaining austenite, which is 50% from here, will start to transform. So that last 50% turns into 25%, and then we quench it down into the martensite.